This AI agent is a better coder than GPT-4o. In today's video, I'm going to show you an AI agent that beats ChatGPT in writing code. We'll walk through the code implementation that creates an AI agent that's capable of generating and testing code solutions automatically. So let's get ready to transform your code development. Let's jump right in. But before we dive into the code, let's break down the workflow of our AI agents using this visual diagram. This flowchart illustrates the key components and processes of our AI agent. We start with the question input. The process begins with the problem statement from the user. This is where you would input your specific coding request as a human. Next, the code generations. This first blue circle represents our AI code generation LLM. This is where the magic begins. Our AI agent takes your request and starts crafting a code solution. The next one is an illustration of the generated code structure. The dashed box shows the structure of the generated code, which consists of three parts. Preamble, basically a brief description or context for the code. The imports, the necessary library imports for the code, and the actual code, the main body of the solution. Next is our code check function. The second blue circle represents the code checking phase. Here our AI agent tests the generated code for errors and functionality. This is important. That's something ChatGPT is not capable of. It gives you some code that may include hallucination or just not properly working code. Next is our decision point or decision edge. This conditional edge is a crucial decision point. It basically asks, did the code fail? If no, the arrow leads directly to the code solution or final working output. If yes, the arrow loops back to the code generation phase and allows the AI to learn from its mistakes and try again. The long arrow at the bottom, leading from yes back to the code generation, represents the iterative nature of our AI agent. It will keep refining and improving the code until it passes all checks. And finally, our code solution. This is the final output. The fully functional, error-free code solution tailored to your specific needs. Now that we understand the flow from our visual diagram, let's dive into the code that brings this AI agent to life. We'll explore some components, but I'm not going into every detail in this video. I will show you how it relates to our flowchart and contributes to our overall functionality. First, the environment setup and imports. Here we are importing necessary libraries like .env, components from LangChain and LangGraph for building our AI workflow. As the framework of our AI agents, I used LangGraph. Here we are importing necessary libraries like .env, LangChain, and LangGraph for building our AI workflow. Next, we're initializing the AI model. Here we're creating an instance of the OpenAI class, which serves as our AI brain. We are using GPT 3.5 Turbo. Now it's not the most powerful LLM model, but I have chosen it to demonstrate that a weaker model can beat ChatGPT 4o within an AI agentic model, an agentic system. The temperature setting equals 0 setting ensures that deterministic outputs, making our code generation more consistent and predictable. Next, defining the code generation prompt. This prompt template is crucial for guiding our AI in generating code. It instructs the AI to act as a coding assistant, provide executable code with all necessary imports and variables, structure the answer in three parts: prefix, imports, and the code block. This directly corresponds with our code generation or generated code structure, part of our workflow chart. The code class defines the structure of our AI output, ensuring it aligns with the three-part structure we saw in our flowchart. Prefix corresponds to the preamble in our diagram. Imports match the imports box. Code represents the main code section. By using Pydantic-based model, we enforce a consistent structure and can easily validate the AI's output. Next, this is important, creating the state graph. The graph state class defines the structure of our workflow state. Error tracks an error in the code generation for our checking process. Messages stores the conversations history. Generation pulses current generated code. Iterations counts the number of attempts, crucial for our iterative process. The state graph is the backbone of our workflow, allowing us to define a series of steps and transition that mirrors the flow of our diagram. This is basically the short-term memory of our AI agent system. Next, we implement the key functions of our code generation. Here, the code generation function. This function corresponds to the code generation circle in our flowchart. Takes the current state as input. Uses our AI model to generate a code solution. Updates the state with the new solution and increments the iteration count. Next, our code checking function. This function represents the code check circle in our diagram. It executes the generated code, catches any exceptions, updates the state based on whether the code passes or fails the test. Next is our conditional edge, the decision function. This function embodies the decision diamond in our flowchart, determining whether continue iterating or finishing the process based on the errors and iteration count. And finally, sampling the workflow. This section constructs the actual workflow. We add nodes for code generation and checking, set the entry point, the generation steps, defining the flow from generation to checking, and adding conditional edges based on the decision function created, creating the loop we see in the diagram. The run code generation function part brings everything together. This function sets up the initial state and runs the workflow. The main block prompts the user for input and starting the process. This corresponds to the question input in our flowchart. By implementing these components, we have created an AI agent that can generate, test, and refine code solution autonomously, following the exact process illustrated in our visual flowchart. Now we can run and execute the code to see for ourselves how the AI agents work. For execution, type python main.py, wait a moment, and then we can type in our question. I use this question from the LangGraph GitHub repository. And here you can see every step, the human message, the AI message. Here you can see the first code generation and checking the code. First attempt failed. Here's the error message. It goes back to the code generation LLM, and there you have it. And in the end, no code test failures and the final code output.